everybody, and welcome to Virtual TrekCon. We have a fantastic panel for you today. We have two very special guests. We have the Deputy Project Scientist for the Curiosity Mars rover, if you can believe that. That is Dr. Abigail Fraeman. We also have another very special guest, planetary scientist, and of course, professional Martian, Dr. Tanya Harrison, co-hosting today. You know this guy. He's a good guy. We love him. We like him. He's the Dean of Natural Sciences at Duke University. He's also an occasional science advisor for Star Trek, Dr. Mohamed Noor. My name is Ryan T. Husk. I haven't done any of those things. I just like Star Trek. How you guys doing?
Great. Glad
Fantastic.
to be here.
How are you?
Awesome. Thank you very much. So first of all, let's just get into it. That was a mouthful, but you guys have done so much cool stuff and we want to know all about it. First things first, though. Abigail, what's your favorite Star Trek series?
Oh, gotta say, Voyager. I'm all about the Star Trek Voyager. Captain Janeway, she's amazing. That's my show.
Awesome.
Choice. They're all good choices.
Tanya, do you have a favorite Star Trek series and why?
I would say Deep Space Nine.
Oh yeah,
it was Voyager when I was younger, but as I got older, Deep Space Nine kind of took over. I really liked how many really badass characters they were, like Dax, who I think inspired me to become a scientist, which is pretty cool.
Mm-hmm. Mohamed, do we know your favorite Star Trek series, by the way?
I always refuse to answer that question.
I thought so. I don't think we've ever heard which one it is.
No, I refuse to pick.
However, you have had a member of the Star Trek Voyager cast speak at your university, have you not?
I did. Yeah, Garrett Wong, who plays Ensign Harry Kim, has come a couple of times actually to speak to my class, the science behind popular science fiction TV and movies. I do that, co-teach that with Professor Eric Spana. So I give him a shout out.
Nice. Can I audit this class? That sounds really cool.
Oh my God, it's so much fun. And we would love to have you as guests too. Holy moly.
That'd be awesome.
Mm-hmm. So, all right, well, let's just get into it. I don't know much about science, but I feel like after this panel, I will. So let's talk about it. Abigail, what does a deputy project scientist for the Curiosity Mars rover do?
Yeah. Well, I guess in Star Trek analogy, maybe I consider myself to be a first officer of the ship.
Ooh, love it.
So, helping to coordinate the entire team of people who's needed to operate this vehicle of exploration that we have exploring the surface of another planet. So I do a lot of interfacing with the science team itself, which is this group of about a little bit bigger than Starfleet crew, about 500 people actually, that is diverse like a Starfleet crew. We're from all over the United States, but also many countries around the world. About, I think, a third to half of our team is actually international.
Wow.
And making sure that we all have access to the tools that we need, helping to guide the big decisions that we need to make. We only have one rover, and deciding where to drive and what rocks to zap with our lasers is really a group decision. And so I help enable those decisions, and I help advise the project scientist, our captain of the mission, in making these big mission level decisions.
Can you elaborate just briefly, like when did this rover get there and what is its overall mission goal? Just to set the stage.
Yeah. Mm-hmm. So the Curiosity Mars rover is the fourth rover that NASA landed on the surface of Mars. There was cute little Pathfinder before that, and then twins Spirit and Opportunity that landed in 2004. Curiosity landed in 2012. And so it's been exploring the surface for almost 10 Earth years now, which is an amazing accomplishment. Everything is still working on the rover. And what we're doing is we're looking to understand the past history of Mars, and in particular, understand whether or not it had the ingredients that could have supported life. So, with these past rovers, we found evidence of water on Mars. We found that there was once liquid water on the surface. So Curiosity is kind of going above and beyond that, saying, okay, well, if there's water, are there other things that life would have needed? Are there things like organic molecules? Are there sources of energy that life could have used? Was the water that was present there for long enough and kind of friendly enough for life as we would have known it? So we're answering those questions with Curiosity. And then you may be familiar too with the most recent rover that NASA landed on Mars, the Perseverance Mars rover, which I see a beautiful selfie of in your background there. And Perseverance is going even beyond Curiosity, continuing to build on that in our search for life on Mars and understanding how Mars evolved. And it's actually collecting a whole bunch of samples that we're hoping to bring back to Earth one day to study in our labs.
The Pathfinder, I believe, is the one that's in the opening credits of Star Trek Enterprise.
It is.
Oh, yeah.
That is correct.
Yeah.
That's my favorite part of the opening credits.
Yeah. Excellent. Not the music.
All right, easy. The music is awesome.
Controversial.
It's awesome. Everybody loves it. Little known fact about that song: everybody likes to poo-poo it, but I have multiple times done polls in giant Star Trek Facebook fan groups and polled them and said, "Hey, do you have a generally favorable feeling about this intro song, or generally negative or positive feeling?" 2/3 of them said positive. So if you like it, and a lot of people like it, but they're afraid to say so because they feel like they're going to get jumped on, you're actually in the majority. People love it. But Tanya, can you tell us a bit about what you do as well? Because we've spoken a little bit before, and your career path is just fascinating. Can you share it with everybody?
It's been all over the place. So I spent my whole career up until about 2.5 years ago doing things on Mars, hence the professional Martian moniker. I've worked on camera systems on Curiosity, Perseverance, Opportunity behind Abby. So Abby and I were actually on the Opportunity mission at the same time.
Wow.
You should ask her about her previous role on Opportunity because it's also pretty badass. And worked on a lot of science, looking mostly at things like landslides on Mars, which might not sound super exciting, but there are a lot of different ways that stuff can fall downhill, enough to do a whole PhD on it, apparently. And for part of my job, separate from the rovers, I also worked on a satellite called the Mars Reconnaissance Orbiter. And so I was a targeting specialist for a camera on there called the context camera, which took big context images for the high-rise camera, which if you've seen any of the really beautiful color images of Mars over the last 15 years, my gosh, it probably came from that camera. And then we also took these global images of all of Mars every single day to monitor the weather. And so I was a Martian weather girl for a while, writing weather reports and letting the rover teams know if there were storms headed toward the rovers. But one day I found out about this company called Planet, which was imaging the entire Earth every day to look at change, kind of like we were doing on Mars with this Marcy camera, Mars Color Imager. And so I jumped ship, came back to Earth, or I guess hopped on a ship, came back to Earth. And now I work with satellites that are taking pictures of the Earth every day to do things like monitor the impacts of climate change, monitor human activity across the surface. A huge difference from Mars. I've realized the Earth is very cloudy all the time, which you don't appreciate so much when you're standing beneath the clouds, but when you're trying to shoot it from space. The clouds are a huge problem, and humans are everywhere. Like anywhere you look, you can see the impact of humans, whether it's a road or a building. They're just everywhere.
We've infested. Quick question for either of you. You can probably both answer this, but I saw something a while back that kind of said, is Mars really red? Now, every picture I actually see of it on ground level looks like it has a tiny reddish hue on the ground, but it's, looks like this basically, right? But when we see it from afar, it's red. Why is that? I mean, is this just like, is this atmosphere we're looking through? What's the deal?
Yeah, well, it's a little bit of both. So, the thing that makes Mars red, and when you see things like Hubble Space Telescope pictures of Mars, or even honestly, if you see it with your naked eye, standing here on Earth, you will see it looks a little bit red.
Yeah.
What you're seeing mostly is light scattering from Martian dust. Mars is a very dusty place, and all of that dust has a lot of oxidized iron, which is basically just saying it's rusty. Rusty dust all over the planet, and that gives it that red color when you look at it, from a distance. Now, the cool thing that you find when you can actually land on the surface of the planet and brush away some of this dust on the rocks is that some of the rocks themselves, they're still pretty red because the rocks themselves are oxidized, but some of them are actually purple, brown, gray.
Wow.
Even some of them are kind of whitish colored, depending what they're made of. And so Mars, when you start to look closer at the details, it's actually quite colorful.
You can see some of the gray rocks in the background behind Ryan, like off to the, I'm looking at off to the left. It's like the lie of Mars. It's not actually all that red once you brush away all the dust.
So where did the dust come from?
Yeah.
It's $1 million question.
Oh, we don't know yet.
Sorry, go ahead, Abby.
No, you go ahead.
I was gonna say, it's been one of the big questions on Mars. Where do you get this, where it's distributed globally? Like what eroded to produce this? And it's obviously coming from like wind erosion of the rocks on the surface. So wind is just blowing over time. But we don't really have a great analog on Earth for how a lot of this happens, because we have the action of things like volcanoes and rain and subduction, so like plate tectonics. So Mars is kind of interesting in that it's just had wind acting on the surface and not much of anything else for about 3.5, maybe even 4 billion years. And it gives a lot of time to pulverize things into dust. Plus, you have a lot of impacts happening over time. And as those impacts happen, they break up a lot of the rocks on the surface, and those break down over time as well.
Mm-hmm. Wow. So here's something I've been thinking about, Abigail, because you kind of flew through something, and I feel like everybody listening in was like, I'd like to hear more about that. And that is looking for life on Mars, or looking for evidence of life, or looking for evidence that life could have existed but didn't. All of those things I feel like are so intricate. And you mentioned, I think you said friendly water, like how friendly the water was. And that is not a term that I could wrap my head around. Can you explain what that means?
Sure. Yeah, I'll start with the second part and then maybe go back to the first part.
Please,
but yeah, when I talk about friendly water, I'm talking about water that you might like to drink. So some of the first water that we found direct evidence for on Mars was with the Opportunity rover. And that was a really exciting finding because it was our first, evidence that there was liquid water on Mars. But we found was that water was probably pretty close to battery acid. It had a really low pH. And, we found life in extreme environments on Earth that could live in environments like that. But it's really hard. And, that might not be the kind of place where life originated. So what we've found subsequently in some of the other places on Mars that we've looked with the Spirit rover, with Curiosity, is evidence for liquid water that was much, much more drinkable. It had a neutral pH around 7. So, we found that Gale crater, where Curiosity landed, was once filled with a big lake that probably stuck around for tens of millions of years. And if you walked over with a lake with a glass in your hand and scooped up the water and took a drink, you'd probably be fine. It would probably taste pretty good. And so that's the kind of exciting finding that we're moving towards and understanding. But yeah, the whole idea about looking for life, that's hard. And it's even harder when you can't actually go out there and look at rocks with your laboratory instruments. We of course would love to find a dinosaur bone or, some gourd around.
That would be case solved right there, right? That's it.
And we're always on the lookout for them. You always make a joke. Well, if we see a dinosaur bone, we'll turn around. But what we're thinking, if life ever did evolve on Mars, it probably was kind of a microscopic life, very, very tiny, single-celled sort of thing. And so for now, what we're looking for is evidence for really tiny changes, looking at compositional changes in the rocks that can only be caused by life. And, this is another reason we're excited to bring samples back, because we can look at them at really the smallest scale to see if we can find any evidence if there ever was life on Mars. We know it would have been a great place to live, but we don't know if anybody actually lived there.
Now, real quick, and I know Mohamed, you're going to jump in too, but do any of these rovers have these kind of capabilities of like microscopes or anything to where they can look at these samples in any great detail, or is this something that we strictly just have to wait until we bring them back?
We have microscopic imagers, but it's not like microscopic in the sense of being able to see a tardigrade swimming around or something like that. It's more like we can see individual grains within the rocks, which is still pretty cool, looking at individual grains of rocks on another planet. And we can specifically say, I want to take a sample with, one of the laser instruments, for example, of that specific part of that rock on this rock that's like this flying rock of Mars that's 200 million miles away. That's amazing. But to be able to do really, really detailed analyses and actually figure out like what is happening inside those grains and like really detailed analysis to figure out, is there life in there? We need to be able to sequence DNA, and we can't do that without bringing it back to Earth.
So back in the late 90s, there was a lot of discussion about these supposed microfossils and Martian meteorites. How would what they see be different from that?
Yeah, I think that's a great example. Just as a reminder, there was this meteorite that was found in Antarctica that we figured out was from Mars. And then there's these very intriguing structures if you look really close in the meteorite. And, they kind of look like they could be tiny fossils. The problem is they're like way smaller than any known life that we know today. Those certainly would probably not be visible with the tools we have on the rover. But that's the idea, is we're looking for really small things, but you need more evidence than just the structure. You need to be able to show that the compositional changes associated with it are what you would expect from life. And you would also need to be able to show that you can't rule out any other mechanisms for these kinds of things to form. So one of the problems with the really small structures in this meteorite is that we could come up with some explanations that didn't involve any biology to make them. And so that kind of is now the default thinking, that is what they are. There's some sort of reaction that occurred in the rock and formed these very, very tiny structures, but not necessarily evidence for life.
In terms of the water, you mentioned water earlier, Abby. I'm assuming the reason we don't see more liquid water as opposed to just, and obviously there's the ice caps which have water, but I'm assuming it's because of the really thin atmosphere. Is that correct?
Yeah. So Mars is super cold and a super thin atmosphere. So water would simultaneously freeze and evaporate right away. So we do see some water ice in the poles. We see water ice buried in the subsurface. We see maybe, although it's controversial, potentially really thin films of liquid water, maybe that come out in the summertime that manage to remain liquid at the surface because they're super salty. Although we're not totally sure if those are water or there's some other thing that's tricking us from our orbiters. We haven't actually visited one of those with the rover.
And Tanya, you mentioned in our other conversation earlier that you sometimes have like clouds that are kind of like cirrus clouds that I assume are water as well.
Yeah, they're made up of little tiny water ice crystals, and so they're really high up in the atmosphere. But you can see them from orbit and from the rovers sometimes when they're looking up at the sky.
Very cool.
Can I just say that this is such a treat having you here? This is like you're answering all of these really interesting questions, and I have to say this is a real treat, and I feel like everybody watching this is going to enjoy this as well. So thank you, first of all, for all of your answers so far. This is a lot of fun, and secondly, not to beat this water thing to death, but this is very fascinating, and I think
Splash.
it's probably one of the most important things of what anybody's ever looking for when they're exploring outward, whether we're talking about looking for life or whether we're talking about something that can give us hints as to what used to be here. But when, again, back to the friendly water, the reason I asked that question was because when you first mentioned that, my thought was, I remember reading back in the day that things that were important to creating life, or at least varied life, was things like tides and seasons, and the fact that when things change, it gives us more opportunity to create life or create more different types of life. And then I was wondering if there was more water on Mars back in the day, if there was any. Is there any possibility for tides on Mars? Is there any planetary body or celestial body, I should say, that's close enough to affect Mars's, the pull of water on Mars, or is it just too far removed from any other celestial body? I would definitely ask.
I'm not sure if the moons of Mars are big enough to have tides. That's actually a really interesting question. No one's ever asked me that before.
All right.
Do you have any idea, Abby?
Yeah, I don't know. So yeah, tides on the Earth, of course, are caused by our moon. Mars also has moons. It has two moons actually named Phobos and Deimos. But they are super tiny. They're like, I think Phobos is the bigger one, and it's something like 21 kilometers on its longest axis.
It's just a
shorter on the
baby.
other side. Yeah. So if you want to run a marathon, you would run the entire moon. And so it's very small. There's theories that Mars maybe had more moons in the past and they have subsequently crashed into the planet. It's just a theory, though. We haven't proven that. So yeah, I'm not sure if the Martian moon would cause tides. If they did, it would certainly be much less dramatic than Earth. Mm-hmm. And, we talk about Mars had water. We don't think Mars necessarily had a vast ocean. But certainly did have more liquid water on the surface in the past than it does now.
So why did it lose its atmosphere?
We think when the core started to solidify as Mars was cooling off after the heat of accretion, as we call it, so the early solar system, everything's kind of smashing into each other, globbing together, forming the planets. There's a lot of heat left over from that, and you have a lot of radioactive heat that's generated from decay inside the cores of these planets. Mars is a lot smaller than the Earth, and so it cooled off more quickly. And when its core solidified, it lost its magnetic fields. And so the hypothesis was that the solar wind, these high energy particles that are just streaming out of the sun pretty much constantly, was slowly stripping away the atmosphere. And amazingly, we were able to prove that with the MAVEN mission that got to Mars in 2014. We actually measured the atmospheric loss rate, and it's something like 100 grams an hour or something like that. It's something that was not an insignificant number. But we've also found some evidence that there's like little pieces of remnants of magnetic field left, because MAVEN also found an aurora at Mars. Probably not anything nearly as dramatic as what we see here with the Northern Lights, but that was very unexpected. We were pretty sure before that the magnetic field was entirely dead. Yeah. So it's interesting. The more we send missions to Mars, we answer some of the questions we sent them for, but then they generate more and more questions. And so we have to keep sending more missions to answer the questions that we get from the previous ones. So people will ask, why do we keep sending rovers? Why do we keep sending satellites? Don't we know there was water on Mars? What else is there to answer? Well, we're filling in more and more pieces. Yeah, there's so much left that we don't know.
Wow.
Yeah, and I can just use this.
Oh, please.
Just jump on the soapbox. The question you answered, Tanya's answers, I think they're also highlighting a really exciting reason why we're studying Mars. We talk a lot about the search for life and, looking for water on Mars, but it's also these questions about how planets work and how they change over time and what makes them go from a habitable place like Mars used to be to this cold, dead world they are today. And, what can we learn about that from a place like Mars? Which is important because, then you start thinking about, okay, we now know that there are thousands of other planets out there around other stars. So what do we know about these planets, and how do we know whether or not they might be good places for life or not? Well, if we don't know how the planets in our own solar system work, it's going to be really hard to figure out how planets in other solar systems work. So I think it's all very exciting, and thinking about eventually in the hopefully Star Trek future, venturing out among the stars and meeting new people from new places. Where would we go to look? So this might all be helping us get there.
That's awesome. So in that context, like connecting to, say, Star Trek, like if somebody were to terraform Mars and give it an atmosphere, it would still just go away eventually, because again, like you said, it doesn't have the sufficient magnetic field to prevent the solar winds from just stripping it off over time again. Is that right?
Yeah, you'd have to be generating it at a rate faster than you're losing it to the solar wind. So the question is that worth it? Should we just live in protected habitats and not try to alter the planet? That brings up a whole other ethical debate about whether we should terraform other planets to begin with, and that could be a whole panel on its own.
Oh. Well, let me write that down.
There's a lot of opinions about whether or not we should change things.
Oh, yeah, there you go, the Genesis
yeah.
Nice.
Yeah. I was thinking about, you were saying, Abigail, a minute ago, you were saying that, maybe I think we're all saying actually, that there's so much more to find on Mars, and that I can't believe there are actually some people, apparently there are, that question the validity of continuing to dig and probe and search within Mars. I mean, we're still doing that on our own planet. So we know 10 things about Mars, you guys. we have to keep digging and finding out more about it, obviously, right? But I've got a question here that I'm really curious about, and that is for both of you. We'll start with Tanya, if that's okay. What do you think is the biggest discovery or answer to a question that we will have in your lifetime with regards to Mars? Is there a question in your mind that needs to be answered that will be before this is all said and done in the next few decades?
Oh, man. I mean, I would hope that the question of whether or not Mars ever had life gets answered in my lifetime, because I really want to know. I think to be able to answer that question for sure, though, we're going to have to send humans there and be able to do things like drill really deep rock cores, kind of like we do with ice cores in places like Greenland and Antarctica. I don't think that we'll be able to answer the question in just, the upper few centimeters of the surface of Mars, just because if there was life on Mars, it was probably, 3.5-4 billion plus years ago. And so I imagine a lot of that is very deeply buried at this point. This is a controversial opinion that I can say now that I don't work on the rovers anymore. And that's, I think, something important for us to keep into mind as well. Even if the samples from Perseverance come back and we don't find life in them, that doesn't mean there was never life on Mars. It just means that we didn't find evidence for it in those samples at that location in those specific rocks. So it's not a failure if we don't find it there. It's just, okay, we tried yet another method of investigating, and this just wasn't what we could answer the question with. My hope, though, of course, is that we send them back and we find amino acids or microfossils or something. That would be amazing. But I have a feeling it's going to be more like these big human missions that will actually answer that question once and for all.
Well, then, sorry, just to follow up on that, would it technically, is it even possible then to rule out the existence of past life on Mars with absolute certainty, being that if we don't find life, that doesn't mean there wasn't any. That just means that maybe it wasn't right here in this hole or in this area here. Do you think we can rule that out with certainty over any amount of time?
I mean, it's hard to prove a negative, right?
Exactly.
So it's tricky. If life was not widespread on Mars at any point, that would be really hard. On Earth, you dig a hole anywhere, even if it's in these battery acid lakes like Abby was talking about, there's something that has managed to thrive there. So we're used to a planet that is literally infested with life. But maybe in Mars, you just had like that one pocket, that one pool where Q was showing Picard the proteins and the amino acids coming together, and it was only there. So yeah, and this is bringing up another ethical debate about, should we be sending humans to Mars before we're sure that there is not or was not life there, because we're going to contaminate it no matter what we do. And will we be able to tell for sure that if we do find life on Mars, it's not something we brought with us? And that's the catch-22. I don't think we can answer the question without humans, but if we send humans, how is that going to impact Mars? It's tricky on both sides.
Even the rovers to some extent, right? I mean, my understanding is that the sterilization done for the post-Viking rovers was not nearly as high as even for Viking back in the 70s.
Yeah.
Oh, that's really interesting. So we may have already contaminated Mars with life.
Hopefully not much.
We do our best to keep things as clean as possible, and also to, if we do bring things, know exactly what it is that's hitching a ride.
So Abigail,
there's no engineers in there like coughing on the rover, trying to like populate a new planet.
Abigail, same question to you. Is there something, even your own just personal question that you've always wondered about Mars that you think will be answered in your lifetime?
Gosh, I mean, the life one I think is the ultimate goal, to be able to answer that, and because that would revolutionize, I think, everything.
Yeah.
If we found evidence for life independently arising in two different planets in our own solar system. But I mean, honestly, what I'm really excited about, and I am feeling very confident will be answered in the next decade, is going back to the Martian moons. I did part of my PhD thesis studying them, and they are very weird, and we don't know where they came from. And different formation models have different implications about how maybe the solar system formed and was mixed around, how water was delivered to the inner solar system. And Japan is actually sending a mission to these moons in a couple of years. It's going to collect rocks from them and bring them back.
Oh, wow.
And so I'm really optimistic that by sending these rocks, we're going to know how these moons came to be. And that's really exciting to me, because I think that's something we're definitely going to have an answer to in the next decade. And I can't wait.
Do we know what those moons are made out of yet?
No, they are very dark. They don't look like Mars. They're very low density. They could be chunks of Mars as Mars formed. They just kind of got left out there. They could be pieces of Mars that were blasted off by an asteroid impact early in Mars's history. Or they could be captured asteroids that came from somewhere else in the solar system, possibly way out past Saturn or Uranus. We have no idea.
Okay, sorry, just one
Expanse?
more. Oh, yeah.
No.
Oh, sorry. Did you say, do you watch?
I was asking for Abby if did you watch The Expanse in terms of the Martian moons?
No, I know, but
for.
I've heard that they're in there, and so yeah.
Yeah, well, that's cool.
Something bad happens to one of them.
It's on my list.
I just wanted to follow up a tiny bit more on those moons, because this is definitely the first I've heard of those. You said there are two of them, and we don't know what they're made of, but do we have any reason to believe that they are made of the same stuff as each other? Like, are they both dark?
Oh, good question.
Or do they both have any kind of similar qualities to where we can theorize they're probably from the same source?
Yes, they are both dark. They both have similar reflective properties. The way they reflect light at different wavelengths is very similar between the two moons. They both kind of look like lumpy potatoes.
We kind of all do, though.
Yeah, both have very low density. They're much less dense than you'd expect for something that's solid rock. So they either have lots of kind of holes inside of them. Maybe they're big rubble piles. Maybe there's some ice inside of them. We don't know. But the really interesting thing is one of the moons, the closer one, Phobos, is slowly spiraling into Mars. And Deimos, the further away one, is slowly spiraling away from Mars. And so how do you get two things that are related but are kind of going in opposite directions?
Yeah.
Yeah.
That doesn't seem to work. Anyway, sorry, Mohamed. I think I jumped over you with like 15 questions about water and moons.
No, good. I was just picking on something from The Expanse. That's all.
Right.
I don't want to spoil it if you haven't seen it.
It's on my. Everyone loves it. It's on my to watch list.
I've only seen
Definitely
the first
worth checking out.
episode. Oh, you've seen it, Tanya?
Oh yeah, I watched the whole thing.
Yeah, you know what I'm referring to then.
Yeah. It's very good. You should both watch all of it.
Yeah, that's what I hear. All right. Mohamed, did you have any questions? You seem like you did.
I mean, I have like a million questions. I was thinking maybe we switched over to Star Trek a little bit, but
Yeah.
up to you guys.
I won't fight that.
So, I mean, in Star Trek, the what is it? The Utopia Planitia shipyard, is that right? I think that's actually on Mars. So, I mean, aside from, we talked a little bit about terraforming, but what would it take to have sort of like a permanent colony there? Even, let's say it is covered or something like that, so you don't have to terraform. What would be the challenges there? I mean, obviously it's cold, there's low atmosphere, but what would be the problems with that?
Radiation is a big one. The radiation environment on the surface of Mars is not awesome for humans if you're going to be there for an extended period of time. There's actually an instrument on Curiosity specifically to measure the radiation levels because we wanted to see, would it kill you immediately? The answer is no, thankfully. Even in some big solar storms, it's not enough that you would, immediately get cancer. But it's something that would
not
build
immediately.
up over time.
Okay.
Yeah. So there's been a lot of propositions of things like building human habitats inside of lava tubes, for example, which are big tubes that are beneath volcanic areas where there used to be lava flowing through them. And then eventually when the volcanic activity stops, it kind of essentially freezes up, it hardens up, and it leaves this empty cavern behind. And they're nice and round. And so you can just kind of stick an airlock on either side, pump your air in it, and you've got a base. Another idea is building them inside the walls of craters or inside the walls of canyons, which would be a much better view than living underground in a lava tube. I would really hate to spend 8 months going to Mars to live underground for the rest of my life. But then, you need the equipment to actually excavate into the wall and build these things. So I think the challenges of construction for the very initial things that we're going to put on Mars are going to be a lot trickier than we're used to, because it's so easy for us to do these things on Earth. But once we get past those hurdles, Mars is kind of convenient in that it has a lot of resources there that we can utilize. There's ice underground, so we can use that for drinking water. We can rip off the oxygen from the water and use it to create rocket fuel to come back to Earth at some point. Those are probably the main things. Oh, and you can take in carbon dioxide from the atmosphere, rip off the oxygen, and then you've got breathable oxygen. So there's an instrument on Perseverance that's actually doing this oxygen generation for the first time on Mars, and it's been working really well. So it's been done on Earth before. It's not a new process, but we never actually tested that equipment on Mars, and it's working successfully.
In terms of the radiation, how bad is it relative to, say, what astronauts here, like in orbit, face? Is it like much worse than that, or is it comparable?
I don't remember the levels. Abby, do you?
Yeah, I think it's about similar to what you get in low Earth orbit. So it's not great if you want to be there for years and years. I will say, recently we're getting into solar maximum where the solar activity has been picking up. And one of the cool things is there's been a couple of big flares that have been shot off, and we've seen the spikes on the surface of Mars go up. So when there's especially intense solar activity, things get a lot worse, a lot quickly.
It also killed a bunch of Starlink satellites recently here on Earth.
Yeah.
I don't know anything about these Starlink satellites. What are those?
Oh, they're satellites that SpaceX has been launching left and right to do satellite internet. They did a launch this month, last month, I forget which one.
Recent,
yeah, very recently. And something about the solar storm hitting at the time that they were launching, they didn't make it to the orbit they were supposed to reach. And so like 40 something satellites burned up in the atmosphere.
Wow.
They're very small though, so they're not going to like fall on someone's house or something, but they lost all of them, which is unfortunate.
Okay. So, I've got another question. Forgive me, but this is so much fun. Picking your brains is amazing. You ladies are brilliant, and this is really interesting. Besides Mars, Abigail, what's your favorite planet in our solar system? You know what? Besides Earth, no easy answers. No easy.
Scientists always say Earth.
Easy.
Yeah.
Mars is great.
And
Earth is much better.
depending on the time of day, no Pluto either. I don't know where we are in that argument right now. So we'll do.
Pluto's not a planet.
What's your? Oh, good. We have dissension between the two. Here we go.
No, that's a good question. And yeah, actually a pretty easy answer for me, and that would be Venus. And that's because it's getting back to my whole excitement about studying these planets that could have once supported life, but definitely don't anymore. And the ability of that to act as a natural laboratory to just study how planets work and what makes them good places to live or not. And so, you know, on one end member spectrum, we have Mars, but on the other side, we have Venus. And, you know, it's actually, if we detected Venus as we detect planets around other stars, we would think that it's right on the edge of this zone that we call the habitable zone, where it would be a great place to life. It could support liquid water on its surface. But obviously living here, we know that's not the case. You know, it's a hellscape on the surface of Venus. And so why is Venus so different from Earth? I think it's fascinating. And we're actually just announced sending a new fleet of spacecraft to go study it. So I'm really excited to see what we find.
I'm just glad that we can say things like that. Launching a fleet of spacecraft. I never thought I'd see the day.
Yes.
Tanya, do you have a favorite planet other than Earth and Mars, or favorite awesome moon around like Jupiter, like some of those that like have a bunch of water, like what is that? Io and Europa. There's a bunch of really cool ones there.
I was going to ask if I could pick a moon. Yeah,
Man,
so
I hope we can go into moons
favorite.
too. Yeah.
I love Enceladus because it has geysers that are just shooting out of its south pole. There's water in there, there's organics in there, and we know that the ocean that the geysers are coming from underneath the south pole of Enceladus is warm. So it could, you know, warm plus water is very good for life as we know it on Earth. So I would love to go through and scoop up some of the geyser material and take a look at it and see, is there anything living in there? Very closely followed by Europa, because I want to know if there are like space whales swimming around in that ocean underneath the ice cap. That's probably the biggest question.
There.
Yeah.
One.
That's the biggest question I want to see answered in my lifetime for like the solar system in general. I want to know if there's life in any of these moon oceans, so Europa or Enceladus. I think the chances of answering those questions in my lifetime is a lot lower than answering the question of Mars, but I just want to see like a penetrator melt through the ice, turn on once it hits the ocean under the ice cap of Europa, and it's just teeming with krill and whales and all sorts of stuff swimming about.
We should just send a fleet of spacecraft over there.
It's tricky because the radiation environment at Jupiter is not friendly to spaceships.
Yeah, I bet. Yeah, but it does seem like from everything I've seen in the past that those seem to have the highest likelihood of current life or even past life, right? I mean, Mars seems like it should have a pretty low chance of it, unless I'm wrong there.
Today,
I think that's right. Yeah. Mars is a lot easier to get to, though, and a lot easier to explore.
Mm-hmm.
It takes us 8 months to get to Mars, but it takes 5 years to get to Jupiter.
I know, we're
and then
so far.
7 years to get to Saturn. The solar system's a big place.
Warp drive. We need that warp drive. But they got the sun to Jupiter in minutes. Yeah.
Mohamed, I think you were saying something.
Oh, I didn't say anything.
Okay, cool. Well, yeah, we just have a little bit of time left. So did you have any other Star Trek related questions, Mohamed? Because I think we veered back into non-Star Trek.
You veered back into science. Well, my Star Trek question was barely a Star Trek question there.
Yeah.
So do you guys have any Star Trek Mars related connections that you really like? I mean, so I'll toss out some examples. Like in Short Treks, there was that Children of Mars episode.
Yeah.
I don't know if you guys saw that. There's a lot of references to Mars and across the various series. I'm trying to remember from Voyager in particular. I remember At one point in time, there was a mistake. Oh, I remember in the episode where the doctor's backup program was found by some people like hundreds of years later. They erroneously said, "Oh, y'all are from Mars." It's like, no, Earth.
Oh yeah, there was definitely. I think there was a Mars episode in Voyager.
Yeah, where they found the logs of the guy that was
Oh,
like
that's
on
right.
the ship to Mars.
But he ended up getting abducted to the Delta Quadrant or something. I don't know. I will say, okay, so my favorite Star Trek real life moment actually has nothing to do with Mars. It actually has to do with the moon, and this was something I was working on about a year ago. A researcher, Shuai Li, came to me with some data about the surface of the moon, and he said, "I think I found a mineral called hematite in the spectral data, which is rust." And this is something that I'd studied on Mars, which is why he came to me, and we looked at the data and thought about it. And it was like, rust on Mars makes a lot of sense. There's oxygen and there's little bits of oxygen in the atmosphere. But on the moon, where there's no water, there's no oxygen, how can you get rust?
Mm-hmm.
And, he came up with this interesting model about oxygen that might get carried from the Earth's atmosphere actually all the way to the moon and interacting with these really small amounts of water on the lunar surface. But there is a Star Trek Voyager scene where they find the rusty car floating in space.
Yeah,
and the scene starts with Captain Janeway going, like, ferric oxide, hydrate.
37s was the name of that
How
episode.
do you explain rust in space where there is no oxygen? And I was like, I had this exact same conversation. Yeah, ours was not a car in Amelia Earhart, but it was still pretty cool.
That's
what
a
was
great
that
choice.
What was that theory you said that your friend told you, Abigail? Like how oxygen could go from Earth over to what was that? You kind of flew past it. And I was like, I have no idea how that could work or what that means.
Yeah, how could the moon rust? It's really interesting. It was based on kind of mapping where we saw the hematite evidence for it appearing on the moon and where it was located, and it seemed to be really concentrated towards the poles and towards certain faces of craters in the poles. And the idea that he came up with was that there are actually models that show that little bits of oxygen from the Earth's atmosphere can travel through the moon among kind of these magnetic field tails. I'm going to be honest, I'm not an expert in the physics of this, but something other people have studied. And when it gets there, there's also, we now know, really small amounts of water that are actually present in the moon, both as molecules worth, really small amounts that's actually created on the lunar surface due to impact of hydrogen from the sun interacting with oxygen in the lunar rocks, and then also just ice itself near the poles. And so the idea is if you have a little bit of heat from like small micrometeorite impacts interacting with oxygen from the Earth's atmosphere with a little bit of water, maybe that's how you could form this lunar rust. But, it's definitely a theory, and we're sending more spacecraft to the moon as well. And so I'm looking forward to testing that and seeing more evidence for that.
Tanya, did you get a chance to answer Mohamed's question about a Star Trek related Mars moment?
Or it doesn't have to be Mars. It can't be.
Well, I have a really good story for this actually, and it goes all the way back to 1999. So 1999. Are you joking?
No.
It's like, wow, I feel really old. There was a PSA that aired during an episode of Voyager starring Robert Picardo, the Doctor, talking about how there was this Mars Millennium Project for students to design a base on Mars in the year 2030. And it was like, go to mars2030.org or something like that. And it was a collaboration between NASA, the Planetary Society, I think the Clinton Foundation or something like that. And I thought it was the coolest thing ever. I was like, I have to do this. I had already loved space since I was like 5 from things like Star Trek to begin with. And then I got really into Mars with Sojourner because I thought it was cool that we were driving a rover on another planet. It's weird to think that Sojourner is the first rover we ever sent to another planet. and that was in the 90s. Like, it wasn't that long ago. So this is all really new for humans. And so I got super obsessed. I like threw myself into this project, and I think I was 13 or 14. I hooked up with the Mars Society, and they had me present my work that I did for the project at their international conference in Toronto. And I was so nervous the whole time. I read my project off of notebook paper, and I like did everything on transparencies because PowerPoint didn't exist yet. But after I was done, I was like, that was so cool. I want to do this for a job. And so, and very recently, I actually I sent the story to Robert Picardo, and I was like, hey, your PSA actually led to me becoming a Mars scientist.
Oh.
And I sent this note actually years ago. I didn't think he ever saw it. And then he mentioned it during the Planetary Society Planet Fest, last year on air. And I wasn't tuned in because I was at work, and I was getting all these texts from people that are like, he's talking about your letter. I was like, what?
Did you say your name?
So, yeah, people knew who it was. They were tagging me on Twitter, and they were sending me screenshots. So I'm really happy that it all came full circle. And then he tweeted at me, and he was like, "Oh, I'm so proud of you." I was like, "Oh my God!" So it's a very heartwarming moment. 20 something years later.
Amazing. That's a great story. Actually, both of them are great stories.
Okay, I've got one more question here for you, if that's okay. And forgive me if anybody's ever asked you these questions before, but it's new to most of us. Let's start with Tanya here. The question is, and maybe this has already been done, and so you don't actually have to theorize, you actually know the answer, but I'm very curious to know if a Mars rover were to scoop up dirt here on Mars in a little Ziploc bag or whatever high-tech stuff you guys have, fly it back, never touches oxygen, never gets contaminated, never nothing, and it brought it directly to you, and you opened up that little pouch and breathed it in, what would it smell like? What do you theorize, or maybe would it smell sulfuric? Cherries? What?
I used to run an entire project at Arizona State University about the smells of space. So
wow.
This was something we questioned.
See, they know everything.
So glad you're answering.
Yeah. So for Mars, we weren't actually sure, because a lot of what causes scent are volatiles, organic material. So when you're smelling dirt on Earth, for example, a lot of that smell is coming from the organics. And so if you don't have something that's we call volatilizing, making its way up into your nose, you don't really tend to smell much of anything. So it might just kind of smell dusty. If you were walking around in the desert here on Earth, the desert doesn't really have much of a smell per se, unless it rains. And then you get maybe the smell of creosote, in Arizona. But in general, you'd probably notice walking around, the dirt itself doesn't really have much of a scent. But the astronauts that have been to the moon said that lunar dust smells kind of like burning meat or gunpowder. And so there's been some question as to what caused that, and if it's actually the dust itself, or it was some kind of interaction with the dust and the oxygen inside the habitat, or something about the astronauts themselves biologically, maybe something was happening to them. It's a really controversial question that they're not actually sure why it has that scent.
How are they able to smell the dust? Forgive my ignorance, but how? I
brought it back
from
the moon.
Yeah, they'd bring it back in, and then take off your suits. So that was where the question was, well, yeah, if it didn't interact with oxygen in the habitat, for example, would you still get that scent?
Yeah,
but we don't have a way to be able to tell that. I mean, you could try to smell the dirt on Mars in the 3 seconds you have before you freeze to death without your helmet on.
No deal. Abby, I don't know if you have anything to add to that. I don't know if you actually studied that.
I think that was a great answer. No, I had a perfume company ask me this once, and a couple members of the Curiosity team, we put our heads together. I think we thought maybe slightly rusty, slightly sulfury, but yeah, I mean, Tanya's right. What causes smell? We don't know if there's a lot of those on Mars, so it probably wouldn't smell great.
Most of the smells in space are not pleasant things. Like somebody created the smell of the comet 67P because one of the common elements on it is essentially the same stuff you find in cat urine. And they decided to synthesize this for some reason. I was like, well, I think we can all picture what cat urine smells like. I'm not sure you needed to actually, use laboratory time to make this, but it answered a question of what that comet would smell like, I guess.
Oh, thank goodness. Thank goodness we know that now. Well, Tanya and Abigail, this has been so much fun. We really appreciate you taking the time out of your very busy days and your energy to explain things, especially to myself and the fans, that you did a good job of kind of keeping it very simple for us, but very interesting. Mohamed had no problem keeping up, so good job there. But really, thank you very much. We really appreciate you taking the time for us.
Well, thank you for your enthusiasm and for asking such great questions. I had a blast chatting with you all.
Yeah,
we have a million more questions.
I hope the viewers don't mind that we talked more about Mars than Star Trek.
They'll live.
There'll be plenty more Star Trek in the com.
Yeah, there's so many more questions to ask about Mars and all the other planets. I mean, you could just go on forever. It's fascinating. It's absolutely fascinating. And the fact, Tanya and Abigail, I'm sure you believe this, that it is fascinating, but please don't think it's only fascinating to you because this is what you do and this is your passion. It truly is fascinating to the average person. It's amazing because, as simple as it sounds, it's a completely different planet, and we've only known one for the entire existence of humankind. How can it not be fascinating? How can it not be just like this thing you obsess over, right? So
you put it beautifully.
Thanks. So with that, and thank you very much, Mohamed, Noor, for co-hosting today and making us sound smart on Virtual TrekCon.
Always happy to be here. Thank you.
Everybody at home, feel free to follow Tanya Harrison. She is Tanya of Mars on Twitter. Great follow. Abigail, I don't know your Twitter handle if you have one.
Yes, it is Abby Frey, ABBYFRAE.
Got it. Is your last name pronounced Fraeman?
Yes.
I should have said Abigail Fraeman.
Weird name. Right. It's a weird made-up name. That's a whole other story.
We'll
I've heard
we'll
it
cover it next time.
20 different ways.
Well, thank you very much to Tanya Harrison, Dr. Tanya Harrison, and Dr. Abigail Fraeman. And thank you to Dr. Mohamed Noor. Everybody else, we'll see you next time. And until then, be nice to each other. Go follow these ladies and tell them how amazing they are. They know, but it's nice to hear. See you soon.